Yes, now I'll show you how you can find linear load. Because here in assignment 7 you need to convert the square meter load to linear load. So instead of kilonewton per square meter, it should be kilonewton per meter. In this assignment you should find ED1, ED2, ED3 and ED4. And because the load are acting in the facade, we need to have it as kilonewton per meter. And all the given information are in kilonewton per square meter. Yeah, first of all, you can read here in the assignment the width of the building is 8 meter and the inclination of the roof is 25 degrees and the height of all walls are 2.5 meter. So now I'll show you how you can convert from square meter to kilonewton per meter. I could, for instance, start with the silt weight from the roof. The DK roof. And I know the silt weight of the roof, it is stated here as 0.60 kilonewton per square meter. And I need to find the linear load, then I need to find the diagonal length. And the diagonal length, that is 4 meter, the half of the width of the house, and then divided by cosinus to 25 degrees. And then the output I convert to kilonewton per square meter. Normally 2 decimals is enough. So the way you do it, you take the square meter load and then you multiply it with the load width, you can say. This is the load width. And in this case you take the diagonal length. The snow load, this K, I can see on the roof it's 0.8 kilonewton per square meter. And now I just multiplied with the load with 4 meter because the snow load are already calculated as vertical load. So it's just multiplied with 4 meter. So the snow load is 3.2 kilonewton per meter, of course. And the same up here. Of course, the output should be kilonewton per meter. Yeah, it's kilonewton per meter. It was my mistake. Of course, the output is kilonewton per meter. Yeah, so I can conclude from the roof. I have 265 kilogram per meter, or 2.65 kilonewton per meter. And from the snow load, I have 320 kilogram per meter, or 3.2 kilonewton per meter. Yeah, and then it's just to continue. I can take here the silt weight from the ceiling. Then I can just read here it's 0.4 kilonewton per square meter multiplied with the load width, that is 4 meter. And then I convert to kilonewton per meter. So from the ceiling I can conclude in the facade there are 1.6 kilonewton per meter, 160 kilogram per meter. The last example, that is if you had the wall, I can take the wall here on the first floor, self weight from the floor, no, from the wall, GK, and then I could state it first floor, and it said here the self weight first floor external wall is 1.20 kilonewton per square meter, and here I need to multiply it with the wall height to find the linear load, and the wall height is 2.5 meters. So I can conclude from the self weight from the external wall on the first floor that is 3 kilonewton per meter, or 300 kilogram per meter. I could, it's the external wall. Yeah, this is basically how you convert from square meter load to linear load. You multiply it with the load widths, and the self weight of the roof, you need to have the diagonal length. For the ceiling and the floors, you simply just take the load width as 4 meter, the half of 8 meter. The load from the floor on the basement, in the basement, you can just ignore, because that load is transmitted directly to the ground, so you don't need to include that when you calculate ED4. But try to solve this assignment then.